Chapter 14, Water Screencast 3. Now, this screencast is focusing on water needs and how we regulate fluid balance in the body. One thing to remember here is that the amount of water that someone needs is individual based on their body size, their level of physical activity, their dietary intake, and also the environmental conditions they find themselves in. Now, what is generally recommended is for as adequate intake, it is 15 cups for men and 11 cups for women. Now, notice that this is beyond the 8 cups a day that we all grew up with probably. So here we're basically indicating that the adequate intake for water is actually beyond that 8 cups. And the thing to remember here is water needs are met when water input and output are actually equal to each other. Here we have an image that's displaying an estimate of water input versus output in a woman. So here we look at the primary source of water is mostly fluid that they consume. Here we have 8 cups. If we look at the water content found in food, fruits and veggies, that accounts for 2 cups. And then we also have water that's produced via metabolic metabolism. Remember the oxidation of glucose, one of the products is water, and that accounts for about 1¼ cup. If we add that all up, it's about 2,800 mils or about 10 cups. Now, here they're basically describing water output using some different terms. In sensible loss, these are going to be these minor, almost non-visible ways in which we lose water. Skin, and that's through perspiration, approximately 3 cups. If we look at lung respiration, that's going to be about 1¼ cups. And then we actually look at water that might be lost in our feces, and that accounts for about a little under ½ cup. But if we look at the majority of water that we lose, and we refer to this as sensible loss, it's going to be via the urine. Here we're basically looking at approximately 6.7 cups that are going to be eliminated. And if we compare input to output, we basically are equal in this particular situation, and that really is the goal that we are striving for. Now, when it comes to regulating water balance, it is the job of the kidneys to do that. If water intake is too low to replace losses, then our blood is going to become concentrated. This will result in a drop in pressure, and this is going to put in play a number of mechanisms in our body to conserve water. And the reason here is because of the drop in pressure due to the decrease in blood volume. Now, the first hormone that we're going to address here is antidiuretic hormone. Now, if you have taken AMP2, you probably have gone over this, and probably in much more detail than we are going to be covering in this class. So this will basically be a summary, or it could be an introduction if you have yet to take AMP2. So in the brain, the hypothalamus will receive signals of an increased blood osmolarity or plasma solute concentration, and that's going to be coming from various receptors. It's going to respond by stimulating the posterior pituitary gland, and the posterior pituitary is actually going to release a hormone known as ADH, or antidiuretic hormone. And then the effector is going to be the kidneys, and it is actually going to cause an increase in water retention by the kidneys, and this should result in increased blood pressure. Now, another function that is associated with ADH is that it is a vasoconstrictor, which also would increase blood pressure by increasing resistance. Here we have a relatively complicated system known as the renin-angiotensin system, and there are a couple of things that are going to be focused here. The stimulus is going to be a decrease in blood pressure. It could be sympathetic activity also. Renin, which is an enzyme, is going to be released, and it will actually convert angiotensinogen, which is a plasma protein that's circulating, that's produced within the liver, and it is going to convert that into angiotensin 1. This is still an inactive hormone. And the conversion will take place within the lungs, and this is through angiotensin converting enzyme. We now will get to the active form, which is angiotensin 2, and this is a very, very potent vasoconstrictor. And so we see that is one of the roles in which the renin-angiotensin system will increase blood pressure. Also, it's going to release aldosterone from the adrenal gland. The impact here will be on the kidneys to increase sodium retention by the kidneys. This also results in a greater amount of water retention, and together we see an increase in blood pressure. Now, when we talk about dehydration, it can be caused by a number of things. Some of the things could be diarrhea, vomiting, a fever, not having the ability to consume sufficient fluids. You could be someone that has diabetes that is not controlled well, someone that has burns, heavy exercise, dry environments, hot weather, high altitude, and probably the worst thing of all is ignoring thirst. Now, keep in mind, by the time you actually are feeling thirsty, you are probably on your way to dehydration. Now, when we look at signs of mild to moderate dehydration, they would be dry mouth and skin, associated fatigue and muscle weakness. There will be a change in the output of urine. The color will be a deep yellow, and the volume will be greatly decreased. There could be headaches, and there also could be dizziness. As dehydration continues, we start to see a greater increase in solute concentration within our blood. This results in a drop in pressure. Heart rate will increase to counteract that and try to increase blood pressure. Kidneys could fail. And then we're looking at seizures, delirium, and coma, and eventually death in severe cases of dehydration. Now, here we're basically looking at the effects of dehydration, and what they're looking at here is body weight loss, so total percentage. So here we have thirst, and then at about 2%, we're starting to experience a stronger thirst, probably a vague discomfort and sense of oppression. Our appetite will probably be relatively low, and we're now starting to see an increase in solute concentration. As it progresses, we're starting to see less movement. Our pace will be much slower. Skin will start to flush, probably be impatient. Some individuals may actually be tired and feel sleepy. An overall feeling of apathy. There is a potential for nausea and also emotional instability. So that's what we expect with about 4% body weight loss. If we're looking even more, we're starting to see tingling in arm, hands, and feet. Lots of incoordination, stumbling, headache. This is when we start to see heat exhaustion. The symptoms of that are going to be faintness, dizziness, fatigue, nausea, headache, increased body temperature, increased pulse, and also an increase in respiratory rate. As dehydration continues, we'll start to experience a very labored breathing, dizziness. At this point, cyanosis, there's going to be a bluish color of the skin that's caused by poor oxygen flow within the body. Speech will become indistinct, and also there's going to be an increasing weakness and increasing mental confusion. As we continue to progress to 10% of our body weight is lost, muscle cramps, an inability to balance with eyes closed, and a general incapacity. There'll be delirium and wakefulness, a swollen tongue. Circulatory at this point in time will be insufficient. There'll be significant hemoconcentration, a major decreased blood volume. We're now starting to look at kidneys failing. Once we lose even more, greater than 10%, we're really looking at increasing the risk of death, especially if this is associated with illness or extreme heat and exercise. Now, on the opposite end of the spectrum, we have water toxicity. And this is a situation that develops when the kidneys cannot remove water fast enough. So now water accumulates in our blood, and it's actually going to result in a dilute plasma solute concentration. This is known as hyponatremia, and this is going to actually, water is pulled into the cells, causing them to swell. The adverse effects associated with this could be headache and nausea, blurred vision. More significant symptoms would include respiratory arrest, convulsion, and a potential for death due to water toxicity.